Hey guys, in this video I want to do a quick review with you guys as an overview to prepare for the exam. Now I've already done a ton of videos and a lot of examples for every specific type, so I want to give you an overview, just sort of refresher, and we can go from there. So let's begin by talking about the major topics we spoke about in this test. There's really just three topics that we're dealing with in this test and this first portion of quadratics. So the very first topic that we spoke about was converting quadratics. So step number 1, converting quadratics. Now when we're talking about converting quadratics, we're dealing from vertex form to standard form, and in general also to I'm blanking out for a second. So we got vertex form, we got standard form. We spoke about how to convert back and forth between those two. And then lastly, when we're factoring, we're also talking about factored form. But the very first thing we spoke about was being able to convert from one notation to another. Okay? And these are the two notations mainly that we dealt with. So we have the standard notation, and then we have the vertex notation. Okay, we spoke about how to convert from one notation to the other. The second topic that we spoke about was how to factor. We spent a lot, if not most of the whole unit, talking about how to factor a quadratic. Also known as the method that I shared with you on how to factor was the Lopez approach. Lopez method, Lopez approach, it's all really just factoring. And then the third, but for Lopez approach, this was always only going to be working when it's in standard notation. So the quadratic has to be written in standard form for this notation to work. Because as we will review in a little bit, we need 3 different variables or 3 different columns in order for them to add up to the middle column. Okay? And then the last topic that we spoke about was actually solving the quadratic. And for these, another way of saying solving a quadratic was we're talking about how to find the x-intercepts. The roots or the solutions. That's really what we're talking about, right? When we're saying solve a quadratic. So if you want to use decimals at that point, you can always find where it crosses the x-axis. So let's dig in a little bit into each one of these topics just to help you review the overall idea behind it, okay? Let's start with converting quadratics. Remember, the very first goal that we spoke about was how do you go from standard to vertex? From standard form to vertex form, this is what we said first, right? We said that these both equations are always going to have the a in common. So we know that we have f of x equals ax squared plus bx plus c. And we're interested in converting it to vertex form. to be a plus k there at the end. Let me clean it up a little bit. So the first thing that we said, right, is that they both have the letter A in common. That's going to be the same number regardless of what form you're converting it from standard to vertex or vertex to standard. And what we said was this. You want to plug in this, if you're giving standard form to vertex, you want to plug in the equation into Desmos. Want to go to Desmos calculator, graph the equation that you're given, and find the vertex. How do you find the vertex? Well, after graphing it, you're going to be able to locate that point right there, the vertex of the graph. That'll be your h and k. And then we said, since a value is the same, we copy it over to this notation, and then we plug in h and k into our standard, or into our vertex equation. And that's how we converted it from standard to vertex. To go the other way around, vertex to standard, we spoke about box method. So if we have from vertex to standard, we spoke about being able to expand the parentheses, and we started with this. We started with this x minus h squared part, and we made a box method with that. So whatever we had, we created a box, and we say let's multiply whatever you're dealing with, x minus h, and we multiplied all of these terms to fill in the box. Once we filled in the box, let me fix that real quick. Right, once we fill in the box, we added up all the like terms, and when we added everything, excuse me, we had some sort of general function. And we said we're able to replace that with the parentheses, right? So step one was to do box method. Once we had box method, we replaced it in here, and we did distribution with the A, and then finally we added the K at the end. So we ended up having something like A distributive property with the whatever it is that we got. And then we did the plus K at the end. So we distributed, and then at the end we added the plus k with the like terms. So we would then have an a x squared plus bx plus, and then the last two numbers were always like terms. So we combined them, and we got ax squared plus bx plus that c value we're interested in. So this is how we converted from vertex form to standard. Right? We start with expanding this using box method, then we distribute the A into what we got, distributive property, and then finally the last two numbers we were able to add them, and we were able to get the plus C. So standard to vertex, we copy the same A, plug it in Desmos to find the H and K, and you got your equation in vertex form. Vertex to standard, the other way around, we expanded this by using box method. We distributed property, combined like terms, and we got our standard form. You can always just plug all of these into Desmos and match them with A, B, C, and D, right? There's always Desmos as a possibility. So you can put in all the multiple choices A, B, C, and D, plug in the question, and see which one matches. That's pretty much what you can do for any situation for converting. The next step that we spoke about mostly, this is the majority of the unit there's a lot of videos about this, okay, and it's called factoring, or the Lopez approach method. Now, the Lopez approach method will only work when it's in standard form. And what we said when we're trying to factor is that we first want to create 3 columns. We spoke about multiple scenarios, like what happens when a equals 1 up here. When a is equal to 1, we're just going to have x times x. And then we're going to find the factors of c, right? What 2 things multiplied to give you c. And we listed everything possible. And we said that the more you list, right, the products, the more you're going to be able to find the combination of what actually adds up to this column in the middle. So we said what 2 numbers multiply. So when you cross multiply, this goes up at the top, we have some number x. Down at the bottom, we would have some other number x. And when they added up, if they added up to this term in the middle, we found our correct factors. Okay? We did that when a equals 1. We did that when a was also not equal to 1. This was always possible, as long as then you started included other numbers here in the front if that's a possibility. Either way, once you find the correct match and add it up to this b term, we said the middle was just to check our work. And that our factors was always going to be horizontally. That's how we would write our factors of this notation. And our solution would end up being f of x equals the factors. I'm going to put plus or minus some number times x plus or minus some other number. Okay, and that's basically the essence, the overall idea of how to factor. If you want to look at more examples of how do you know when a equals 1, when a is not equal to 1, how do you factor it when they all have something in common? Because we also spoke about, well, what happened if they all are divisible by 2? Then you would take that 2 out, and then the rest of the factors would be in place. Now, this is factored form. Okay, the purpose of factored form is for you to be able to then do the next step, which is our last step, which is find the x-intercepts. Okay, so we take these factored form, and we're able to find the x-intercepts by setting them equal to 0. And I'll show you that in the next slide. So when we're solving the quadratic, right, we're really looking at whatever factored equation you have. So I'm going to take what we just did earlier. It's supposed to be an x. Right? And we're interested in the solutions, right? When I was explaining this for the first time, I said that the solutions or the factored form are also known as the x-intercepts. We're trying to figure out where does the graph touch the x-axis or the roots or the solutions or the x-intercepts. We're trying to find those 2 locations. And at those 2 locations, whatever the x value is, we know that y is always going to be 0. And at this other x value, the y will also be 0. So what we said is we changed this y value, this f of x, we changed it to 0. And then we set each individual factor equal to 0. Because we want to figure out when is each of these going to equal 0. So we did the first one equal to 0. And then we also did the second one equal to 0. And then we just solved for x for both scenarios. And that's how we found our x-intercepts. Okay? Now, obviously, you also have Desmos, so if you wanted, you can always plug in this equation, your general equation or the factored form if you want, whatever form of the quadratic you were interested in solving, plug it in Desmos, and then go to the graph and click on those points. What are those 2 points? And there are several ways of writing these solutions, right? You can write it as x equals. You can write the solutions as x equals a number, other number, right? You can write it as a solution set, where you put the x value and the other x value. or you put it here, as we said, as points or locations like x-intercepts. You can write them like this. There's a lot of ways of writing x-intercepts, right? These were the three main ones that we spoke about. All right, guys, I hope this gives you a quick overview of everything that we spoke about. We spoke about converting quadratics from vertex to standard, using the Lopez approach to be able to find the factors of any quadratic that is factorable, and then lastly, using those factors to find the solutions or solve for x-intercepts. Okay, I hope you guys are doing great. Please let me know if you guys need anything, and as always, I'll calculate later.